Today we're going to continue our factoring unit by talking about the zero product property and how to use the zero product property to find solutions, especially to some quadratic equations. So the steps are listed here for you. The first step is to solve by factoring. So we want to set the equation equal to 0, just like we did in the previous unit with our quadratic formula. So you want to get all your terms to the left side of the equation, get 0 to the right side of the equation. Once you've done that, then you're going to look to see if you can pull out a greatest common factor from all of your terms. After pulling out your greatest common factor, we're going to decide which of these methods of factoring we're going to use. So the first step obviously was to pull out that greatest common factor. Once you pull out the greatest common factor, you want to see if you're left with an equation where you have this ax squared plus bx plus c where a is equal to 1. In that case, you're just going to use the x method. If your a value does not equal 1, right, say you have like 3x squared minus 2x plus 7. So if the a value does not equal 1, then you want to use the x method and split your middle term into 2 terms and then factor by grouping. If you have 4 terms, right, 4 terms is the giveaway for factor by grouping. Split it up into the first 2 terms and the last 2 terms. Take out the greatest common factor from each. And then this final one is the difference of squares. Remember, you have 2 perfect squares that are being subtracted from each other. So you're going to factor by just finding the square root of each of those and creating conjugates for the factors. So once you've factored it out, you're going to set each factor equal to 0 and solve. So there's a little typo there. So we're going to set each factor equal to 0 and solve for that variable. So the zero product property states that if you have 2 things that are being multiplied together and your product is 0, so in this case if a times b is going to equal 0, the only way that that is possible is if a equals 0 or b equals 0. So since we don't know which one of them is going to be equal to 0, we're going to set both factors equal to 0. Right? So if you're multiplying 2 things together and your answer is 0, one of those 2 things has to be 0. So you want to set each equal to 0 and figure out which one or what the values of the variable would be to make that factor equal 0. So we're going to get into some of these examples here. So this first one is nice because it's already factored for us. So looking at number 1, they have the 2 factors k plus 1 and k minus 5. Notice that on the right side here, our equation is already set equal to 0. So if these 2 things are getting multiplied together to equal 0, that means that one of them has to be 0, right? So what we're going to do is take each of these factors, so k plus 1, set that factor equal to 0, and then also our second factor, k minus 5, set that one equal to 0 as well. Now you're going to solve each case. So in this case, to solve for k, we're going to subtract 1 to give us a negative 1. And over here, we're going to add 5 to both sides to give us a positive 5. So there are 2 solutions. K is going to either be negative 1 or positive 5. So both of those solutions would give us the product of 0 when we multiply those factors together. So that one was nice because it's already factored for us. The rest of these we're going to have to factor ourselves. So looking at number 2, we have x squared minus 11x plus 24 equals 0. So once again, you want to make sure that your equation is set equal to 0. So all your terms are on the left side. The right side just has a 0. And next you want to determine if you can pull out a greatest common factor. So remember here, even though it's not visible, really we have a 1 in front of the x squared term. But looking at 1, 11, and 24, there's no greatest common factor between those. So we're going to then determine which of these methods we're going to use from the 5 above. So remember in this case, we have factoring when a equals 1, factoring when a does not equal 1, factor by grouping. So remember the factor by grouping, there we would have 4 terms. We'd split them in half, and then the difference of squares really is just going to be 2 terms. So both of these have 3 terms when we have an equation in ax squared plus bx plus c. So in this case, we're going to choose one of those first 2 methods, and for this one, since our a value is equal to 1, we're going to use the factoring when a equals 1. So as a refresher, when we go to factor and our a value is equal to 1, all we're going to do is use our x method. So we're going to set up our x method by, remember, taking A times C up top, B down below, then looking for factors of the top number that add up to the bottom number. So 1 times 24 gives us 24 up top and negative 11 down below. So remember, if we're trying to multiply these numbers together to get positive 24 and add together to get negative 11, both our factors are going to need to be negative. So in this case, we're going to wind up with negative 8 and negative 3 as the two factors. So multiplying those two negatives together give us positive 24, and they add together to give us negative 11. So the next step would be to take those factors, combine them with the variables in sets of parentheses. So here we're taking x, combining it with our factor negative 8, and x combining with the factor negative 3, and it's still equal to 0. So all we've done here is take those two values that we found using this x method and plugging those values in with a variable. So after we've factored out and found these factors, so these two things are getting multiplied together to equal 0, so we're going to set each of them equal to 0. So I'm going to start by setting x minus 8 equal to 0, and then also x minus 3 equals to 0. So now we can solve each of these just using our simple inverse operations. So we find that x can be positive 8 or x can be positive 3. So those would be your two different solutions, positive 8 and positive 3. So when you plug those values in, that will make at least one of these factors 0. So when they get multiplied together, your product will be 0. Let's look at another example. Looking at number 3. Once again, this time our equation is not set equal to 0. So to start, we want to get everything over to the left side. So in this case, we want to cancel out this positive 5 by subtracting 5 from both sides. So then I'm going to list it out in order of degree from highest to lowest. So I have x squared plus 4x minus 5 is equal to 0. So remember, you always want to get the right side of your equation equal to 0 before you start to factor. So now you want to look at it, make sure there's no greatest common factors that can be pulled out from these terms. And looking at these terms, there's no greatest common factor that will come out of 1x squared, 4x, and 5. So next we want to determine what method we're going to use. So once again, for this one, we're going to use the method where our a value is equal to 1. So you can see that there's a 1 in front of x squared. So once again, we're just going to set up our x method. So 1 times negative 5 up top, and our b value down below. So we have negative 5 up top, 4 down below. So if we're multiplying these numbers together, the factors that we're going to use are going to be positive 5 and negative 1. Those two numbers multiplied to give you the top number, negative 5, add together to give you the bottom number, positive 4. So remember, we're going to take those factors, plug them in the parentheses with our variable. So we have x plus 5 and x minus 1 as the two factors that are being multiplied to equal 0. And once again, right, these numbers are just coming from that x method. So now that we've factored it out, we want to set each of these factors equal to 0 using our 0 product property. So x plus 5 equals 0, x minus 1 equals 0, and then solve for each equation. So subtracting 5, we get x is equal to negative 5. Adding 1, we get x is equal to positive 1. So here are the two solutions for number 3, negative 5 and positive 1. So both number 2 and number 3, we're using that method to factor in when a is equal to 1. So remember, that's just the x method. Let's take a look at number 4 now. So once again, you want to get this equation equal to 0. So I'm going to move anything that was on the right-hand side over by using opposite operations. So that leaves us with 4a squared minus 4a is equal to 0. So always start by getting that right-hand side equal to 0. And now determine if we can pull out the greatest common factor. So for this one, you notice that looking at those two terms, there is a greatest common factor between those two terms. So 4, and then also we can factor out the variable a. So if we factor out 4a from both the terms, we'd be left with a minus 1. So here we've just factored using the greatest common factor method. So pull the greatest common factor out of each term. And then now we're going to set each of these factors equal to 0. So remember that these things are being multiplied together. So both of these are factors. So here we're going to set the first factor 4a equal to 0, and then set our second factor a minus 1 equal to 0. So solving for the first one, we're just dividing by 4. 0 divided by 4 ends up being 0. The second one, just adding 1 to both sides to get a is equal to positive 1. So here we have our two solutions, 0 and positive 1. So once we got everything to the left-hand side, the method that we used this time was just the greatest common factor method. Pull the greatest common factor out of our two terms and set each factor equal to 0 and solve. So let's look at the previous page, right? We have these options for factoring. So one of them is factoring when a does not equal 1. So we're going to your methods out of these 5 you were using. You always want to start here with point out this greatest common factor. So always start with that first step, point out the greatest common factor, and then look at the expression you're left with to determine if you're going to use the x method, so factoring when a equals 1, the x method, and then splitting the middle term when a does not equal 1, factoring by grouping when you have 4 terms, or factoring the difference of squares when you have 2 perfect squares that are being subtracted from each other. So just go through your steps. Once you've found your factors, set each factor equal to 0 and solve for your variables. A couple more problems. Number 5 here. It's already set equal to 0. So the first step's taken care of for us. Now we just need to determine if there's any greatest common factors you can pull out. So in this case, there is a greatest common factor between these two terms. So they both have an x variable that can be factored out. And also a 4 will go into both of those coefficients. So factoring out 4x would leave us with just x plus 7. So once we've factored it out, remember these two things are getting multiplied together, and once they get multiplied together, answer is 0. So that means that one of these factors is going to have to equal 0. So we're going to set each up equal to 0. So setting the 4x up equal to 0, and also the factor x plus 7 equal to 0. Now we want to solve both cases. So first one, we're just dividing by 4 to get us our solution x equals 0. Second one, just subtracting 7 to get us x is equal to negative 7. So remember, once you factor it out and find your factors, you're just going to take each factor individually, set it equal to 0, and then solve for your variable. So these past two, we've just used the greatest common factor method. Problems 2 and 3, we used the when a equals 1 factoring method for trinomials. And then this last one, number C, is probably going to require us to do the most factoring. So let's start by getting our equation equal to 0. So subtracting the 5x squared from both sides. Remember, when we list these out over here, we're going to list them in order of degree from highest to lowest. So 3x to the third minus 5x squared minus 8x equals 0. So first step, get everything to the left, set equal to 0. Now we want to determine if there's any greatest common factors that can get pulled out. So in this case, we do have a greatest common factor. So looking at all the terms, you notice that all the terms have an x variable. So the first step is we're going to factor out the x variable. So that leaves us with 3x squared minus 5x minus 8. So now that we've taken out the greatest common factor, we still need to look at this expression that's inside the parentheses. So going back over here, we were left with expressions that could not be factored or simplified, right? In that case, it was x plus 7. But over here, we left with this trinomial, 3x squared minus 5x minus 8. So that trinomial can still be factored. And notice what is our a value in this case. So remember, the a value is the value that comes before your variable squared term. So in this case, our a value is 3. So we want to use that method of factoring when a does not equal 1. So going back to refresh our memories on how to do that. So remember that in this case, when a does not equal 1, you're still going to start with your x method. A times c goes up top. So in this case, 3 times negative 8 gives you that negative 24 up top. Your b value down below, negative 5. So what are the factors of negative 24 that add up to make negative 5? So as you look through there, we're going to end up with a positive 3 and a negative 8. So those numbers multiply to give you negative 24, add together to give you negative 5. So when a does not equal 1, remember you're going to have an additional step. So we still have our greatest common factor out front there. And then what we're going to do is split up this middle term into those two terms that we found. So remember, what's going to happen is we're going to take the negative 5x and split it up into positive 3x and negative 8x. So we're going to get those values simply by taking the factors that we found and using those factors to split up the middle term. So you're going to add variables to them and split up the middle term. So we're splitting up negative 5x into positive 3x and negative 8x, which we got from our x method. Now that we've split it up, we have 4 terms. So remember, now you're going to go ahead and factor this by grouping. So split it in half, taking the greatest common factor out of each half. So we still have this x that's out front. We don't want to forget about the x that we factored out in the beginning. But here, looking at our first 2 terms, 3x squared and 3x, we can factor 3x out of that, which would leave us just with x plus 1. Remember, when we factor by grouping, we also want the expression left in the parentheses for our second half to be the same. So we want x plus 1 left in parentheses. So you see, out of our last 2 terms, negative 8x and negative 8, we would need to factor out a negative 8 from each of those. So once you've found your greatest common factors from the first half and the second half, you combine those greatest common factors in a set of parentheses. So here we have that 3x minus 8 and also the x plus 1. So here we have our 3 factors now. So remember, here we took the greatest common factor out early on, factored out the x. Then we were left with a trinomial where a did not equal 1. So we did our x method, took the factors, split the middle term in half, and then since we had 4 terms in the set of parentheses, we factored by grouping, right? So looking at the first 2 terms, taking out the greatest common factor, looking at the last 2 terms, taking out the greatest common factor, combining those greatest common factors, and then also using the expression that was left. So here we have 3 different factors, which is going to give us 3 different solutions, which makes sense because here, looking back at the original equation, we had our variable be taken to the power of 3, right, or cubed. So looking at setting each of these factors up equal to 0. So starting with x, I'm going to set x equal to 0. I'm also going to take 3x minus 8, set that equal to 0, and our x plus 1, set that equal to 0. So we know if we multiply these 3 factors together, one of them is going to have to equal 0 in order for the product to be 0. So this one is already solved for you. No steps needed there. Over here we want to add 8 to both sides and then divide by 3. So we have 3x equals 8. Divide by 3 to get x is equal to 8 over 3. And for the final one, subtracting 1 from both sides will give us x is equal to negative 1. So our 3 factors here, or 3 solutions I should say, are x equals 0, x equals 8 over 3, and x equals negative 1. So remember, first step is always to get your equation set equal to 0. Once it's equal to 0, you want to factor what's on the left side of the equal sign using one of our 5 methods there that were listed in the beginning. So determining